Curious Calculator. In today's video, we're going to be going over inverse functions. Today's video is going to be a little bit on the long side, so if you would like, you can skip around to the different sections. Alright, so let's get started. First, we're going to begin with defining an inverse function. So, the inverse function can be defined as follows. The function g of x is the inverse function of f of x if and only if f of g of x equals x for all x in the domain of g of x, and g of f of x equals x for all x in the domain of f of x. So we can also say that the function g of x is the inverse function of f of x if, when we compose f of x and g of x, we get x, and when we compose g of x and f of x, we get the output x. We can note here that the domain of f of x is going to be the range of g of x, and the range of f of x is the domain of g of x. Or in other words, the domain and range are just swapped. And another way to think about inverse functions is that what we're really doing is we're switching the inputs and the outputs. So the x values and the y values are essentially just getting swapped. And we're going to see that here with some of the examples. So let's get into some of these now. I would like to begin with looking at, let's say we have the function that's defined as, let's see, f of x is defined as 1, 2, 2, 5, and 4, 7. So the function just consists of these 3 points, and we want to find the inverse of this function. And whenever we write the inverse of a function, we denote that by just writing f to the -1 of x. And that's how we denote the inverse function. Now, in order to find this, what we're going to want to do is we're just going to want to swap the x and y values. And so looking at this first one, instead of 1, 2, we're going to have 2, 1. And for the next one, instead of 2, 5, we swap that and we're going to get 5, 2. And for this one, we're going to swap it and get 7, 4. And that's going to be the inverse function of f of x in this example. Let's see, I'd like to give another example here, something else you might see. Let's say we have a function f of x that's defined as follows. So this is f of x, and we have that there's 1 here. I'm going to go ahead and write, let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4. And let's say it starts here, goes up to 2, 2, over to 3, 2, and then let's see, 4, 3 right here, and 5, 4. Something like that. And we're asked, okay, let's see here. What can we say about, first off, what is f of 3? Well, to find f of 3, we're just going to look at the x-axis here. I'll even label these x and y. And so we see, okay, when x equals 3, then f of x equals 2. Well, then we might be asked, well, what's f inverse of 3? In order to find the f inverse of 3, instead of looking at the x-axis and locating 3, we're going to instead look at the y-axis and locate 3. And so looking here, we find 3, it's right here, and the x value when y equals 3 is going to be 4. So we're reversing the way that we do this. And let's look at another one. Let's say, what's f of 4? Well, when we're just looking at f of 4 and not f inverse of 4, we're going to look at the x-axis, locate 4, and then find its y value, which is going to be 3. Well, now let's look at what is f inverse of 4. Well, we're going to look at the y value now. So we want to find 4 on the y-axis and then locate what its x value is, and that's going to be 5. All right, let's look at what is f of 5. Well, f of 5, we find 5, and that is going to be 4 here. What about f inverse of 5? What's that going to be? Well, if we look on the y-axis and try to locate 5, we're going to notice that at that point, there is nothing defined for the x value. And so in this case, f inverse of 5 is going to be undefined. That was kind of a trick question there. All right. So those are two examples there. Let's look at some other ones that you might see. So let's say that we want to find the inverse function of y equals x. Now, how can we do that? Well, like I said earlier, the inverse function is really what you're doing is you're swapping the x and y values. So if we want to find the inverse of y equals x, in this case, all we need to do is, so let's say, well, we just need to switch the x and y. So let's say that this is the original function, and the inverse function, well, we switch. So instead of writing y here, we write x. And then instead of writing x here, we write y. And so the inverse function is just y equals x. And in this example, it's a little hard to see why one is the original function and one is the inverse function because they're essentially the same function. But let's look at how this might change and we can see a little bit more of a distinction here. So let's say that instead of given the function y equals x, we're given the function y equals x plus 2. And we want to find the inverse function. Well, we're going to do the same thing. Instead of writing y there, we're going to write x. And then instead of writing x here, we're going to write y plus 2. Then we're going to solve for y. And so y equals, well, we can subtract the negative 2 from both sides. So x minus 2 equals y. And then we can write that as y equals x minus 2. So now we can see where the inverse function is different from the original function here. And let's go ahead and check this one just to show that it actually is the inverse function using the definition of an inverse function, which is the one involving the composition of functions. So if we write our original function, y equals x plus 2, and then we substitute in the inverse function here. So where we have, let's see, y equals f of x. Let's instead write this as, I'm going to write this as f of x. So this equals, I'm going to say f of x equals x plus 2. And the inverse function, I'm going to write this one as, let's see here. This is the same thing as f inverse of x equals x minus 2. Okay. And so now we're going to substitute in this inverse function into our original function. So when we do this, we're going to have f of f inverse of x equals, well, that's going to be, wherever we have x, we substitute in this whole function. And so it's going to be x minus 2 plus 2, which equals x minus 2 plus 2. The 2's will cancel out, and we're just left with x here. And so that works out in that direction. Now let's check it the other way around. So we're going to do f inverse of f of x. We're going to compose these functions the other way around. And in that case, we're substituting f of x into the function f inverse of x. And so we're going to get x plus 2 minus 2, which equals x plus 2 minus 2, and the 2's cancel again, and we're just left with x again. So those do look like the inverse functions of one another. And at this point, the domain and range, they're going to be the same, which is going to be all real numbers for both the domain and range. We can note here that we can see with the original function, the domain here, we can put in any value of x, and that will be fine. And then again, the range will be any value, any real number. And the same goes for the inverse function here. Let's look at an example where we might see something different with the domain and range. And, oh, my bad. Okay. So let's see here. Let's say we're given the function f of x equals x squared. And we want to find the inverse function. Well, we can write this as, so this is, we can say is y equals x squared. Now I'm going to swap the x and y and then solve for y again. So let's say that, let's see, f inverse of x equals, well, let's solve here. So I'm going to swap these, I'll do it right here. So x equals y squared. Solving for y, we take the square root of both sides. X equals y, and we can rewrite that as y equals the square root of x. And I'll kind of keep that off to the side. So we know now that the inverse function of f of x is going to be the square root of x. Okay, so we have our two functions here. And let's kind of play around with some things and check the domain and range. Let's see here. The domain for the original function f of x is going to be all real numbers because we can plug in any value into x here and that will be fine. And the range of our original function is going to be all values greater than or equal to 0. So I'm going to go ahead and write these out. So I'm going to say f of x, let's see, the domain, so x is x, let's say x is all, can be all real numbers, and y is greater than or equal to 0. And then for f inverse of x, let's see, what can we do? We can have, well, looking at it, x can be, right now, you might think that, well, whenever we have the square root of something, we can have both the positive and the negative values. But if we do that, then the function, well, it won't be a function because we'll have something that, well, it's going to have two y values for one x value. If we imagine here that on a graph, we were to graph out the square root of x without restricting it, then this graph will look something like, we're going to have this, and then we're going to have this here. So we'll have both these branches. And of course, this right here is not a function. As we can visually tell, it doesn't pass the vertical line test. And so we're going to have to restrict the domain in some sense so that our range is also restricted here. And looking at this, what we're going to do is we're actually going to restrict ourselves to only the positive x values. And one way that we can do that as well, the domain and range are swapped for the function to the inverse function. So like I said earlier, the domain and ranges are swapped. So if our range on our original function is y must be greater than or equal to 0, when looking at the inverse function, we're going to swap that. So instead of it being the domain, we know our instead of the range being greater than or equal to 0, now our domain must be greater than or equal to 0. And in that case, if our domain is greater than or equal to 0, we're only going to have positive outputs here. So instead of having this right here, we're going to instead have this, which is good because we want a function. And now we can see here that our range is actually going to be only positive values and including 0. So our range here is actually going to be y is greater than or equal to 0. And at this point you might notice, hey, didn't you say that the domain and range are swapped? What's the domain of one is the range of the other, and what's the range of one is the domain of the other. But in this case, f of x, we have that x can be all real numbers, and then the range is y is greater than or equal to 0. So those aren't perfectly swapped. Well, what we're going to have to do is we're going to have to restrict the domain for our original function so that the domain and range are perfectly swapped. So now we're going to go back and we're going to modify the domain on our original function. And this new domain is going to be that x must be greater than or equal to 0. And now we have our domain and ranges for the function and the inverse function, and they're perfectly swapped. And then also, yeah, so I was going to say, well, another way that you might see this too is that whenever you are solving for the inverse function over here, we might notice that whenever you substitute in the x is equal to, so that you substitute in the x for the y and the y for the x, and you get this equation here, x equals y squared. You might notice from right here that x cannot be less than 0 because y squared is always going to be a positive number. So that's just another way you might see that as well, the restriction on x. Okay, I think that's going to wrap up with this one. I'm not going to do the function composition for this one. Maybe I'll do that for the next one. Yeah, so let's go on to the next example here. The next example I wanted to go over was, let's see. Let's say we have y equals x squared plus 2. Okay, so now we've got a transformation. This is a vertical shift up 2 units. And so this is going to be, right, this is f of x. And we want to find f inverse of x. Well, in order to do that, we swap the x and y and solve for y again. So we're going to have x equals y squared plus 2. And x minus 2 equals y squared. Taking the square root of both sides, we get that the square root of x minus 2 equals y. And I'm going to write that as y equals the square root of x minus 2. And kind of leave that off on the side. So we know that our inverse function, f inverse of x equals the square root of x minus 2. Okay, and I'm going to go ahead and then write this as x squared plus 2. Okay, At this point, we have our original function, our inverse function. That looks good. Now let's start thinking about the domain and ranges for these. So the domain for our original function, looking at that, if we just consider this, x can be all real values, right? And so we can say x can be all real numbers. And the y, well, because we have x squared plus 2, well, then the y value, the range is going to be restricted to all values greater than or equal to 2. Because the smallest value we can input for x is 0, and when we do that, we get the output of just 2. So y is going to be greater than or equal to 2. Now let's look at the domain and range of our inverse function. So the inverse function, right, it's similar to the last example I gave where, yeah, whenever you have the square root of something, you typically consider, oh, well, it can be both positive and negative. But in this case, because we want it to be a function, it's only going to be the positive values here. And so instead of this function having the two branches, right, coming out, we only want it to have the top branch. And this one, x minus 2, so let's see, that's shifted over right 2 units. There's a transformation right 2 units. So it's going to be somewhere like right here, and then it's going to kind of branch out. Okay. And in another way, like I said earlier, that you might see that, well, the domain, we're only going to restrict it to positive values only, is by looking over here and seeing that, well, when we try to solve for the inverse function, we have x equals y squared plus 2, we can know here that, what can x be? The smallest value of x that we can have here is 2, and that's going to be when y equals 0. And that's the same case here. If we want to keep the square root only positive, then the smallest value that we can possibly put in here is going to be 2. And that's because 2 minus 2 is 0. Anything smaller than that, we're going to be in the negative numbers. And so the domain for this is going to have to be x is greater than or equal to 2. And that matches up with the range from our previous one, which is what we want. And the range for this function is going to be that y is greater than or equal to 0. But we can notice here that, well, in this case, the domain from our original function doesn't match the range of our inverse function, which is what we would like. So again, we're going to have to modify the domain of our original function here. And we're going to do that by restricting it to all values greater than or equal to 0. And let's see here. So we're going to say, let's cross this out. And this is now going to be that x must be greater than or equal to 0. Okay. I think, oh yeah, and then I did say that I would verify this one using function composition. So let's go ahead and do that real quick. Our original function, f of x, so I'm going to do that right here. F of x equals x squared plus 2, f inverse of x equals the square root of x minus 2. And so in this case, f of f inverse of x equals the, let's see, square root of x minus 2 squared plus 2, which equals, these are going to undo each other. And so we're just left with x minus 2 plus 2, which equals x minus 2 plus 2 equals x, because these are going to cancel out. So it checks out in that one. Let's check the other way around. f inverse of f of x, oops, I forgot that right there, equals, well, we're going to substitute the other way around. So now we're going to have the square root of x squared plus 2 minus 2, which equals the square root of x squared plus 2 minus 2. The 2's are going to cancel out here. So we have the square root of x squared. Those are going to undo each other, and we're just going to be left with x again. So those are the true inverses of each other, and we have modified the domain of the original function so that the domain and ranges are swapped. All right, awesome. Let's go through another example here. So in this one, I want to look at y equals the square root of x. And so that means that f of x, our original function, equals the square root of x. And we want to find the inverse. Well, I'm going to do that over here on the side. So I'm going to swap the x and y. So x equals the square root of y. Solving, I'm going to square both sides. So x squared equals y. And I'm going to write y equals x squared. So we know that f of negative 1 of x, or f inverse of x, equals x squared. Okay, let's start considering the domain and ranges for these. So the domain of f of x is going to be, well, x must be greater than or equal to 0, because we can't have the square root of a negative number. So x must be greater than or equal to 0. And let's see. The range is going to be that y must be greater than, 0, greater than or equal to 0. Right, because whenever we're taking the square root here, if our x values are greater than or equal to 0, then that means that our range values are also going to be greater than or equal to 0. Okay, and let's see here. If we have, I'm sorry. Yeah, well, okay. Actually, let me modify that last statement. So it's not necessarily that because our domain values are greater than or equal to 0, our y is greater than or equal to 0, right? Because if we have let's say x is 100, we could say, oh, well, you could have, 10 squared or negative 10 squared, and both of those will equal 100. But the thing is that typically if we're told that f of x is a function, then what that means is that this function is only being restricted to its principal branch. It's only going to be restricted to values that where the range is only the positive side. Because if we took both the positive and negative y values, then this function that we're given wouldn't actually be a function. So we know that in this case, the y must be greater than or equal to 0, given that it is, in fact, a function. Okay, and now let's consider the f inverse of x. And in this case, the domain, we would say, oh, well, the domain can be all real numbers. But that wouldn't line up with the range from our previous one. And so we're going to have to modify this in some sense. And we modify, well, it's not necessarily that we modify it, but we have to take into consideration what the range of our original function is. So the domain and range are really going to act as our guides for the domain and range of the inverse function. And so first of all, they're going to restrict the domain and range of our inverse function as much as they can. And then if things need to be modified more, then we'll have to jump in and do that. But because the range of our original function, which is y is greater than or equal to 0, will in fact restrict the domain. So we're going to have x is greater than or equal to 0. So we're just gonna use that modification right there, or not necessarily modification, but just the original range is going to influence what the domain is of our new or of our inverse function. And so we're just automatically, I guess you could say it's a modification on the inverse function, because typically we would say that x can be all real values, but we're restricting it because of the range of our original function given here. Okay, so now we have the domain here. Let's consider the range. Well, the range, whenever we have something squared, that's always going to be positive. So we know here that the range must be y is greater than or equal to 0. And in this case, we can see now, well, we have the domain and ranges are exactly swapped, and that is all good. Okay, so I'm not going to look at the function composition for this one to verify. I'll do that with the next one here. Okay. The next one I wanted to look at is y equals the square root of x plus 2. And so that means that f of x equals the square root of x plus 2. Let's go ahead and solve for the inverse function here. So we're going to swap the x and y. And we have x equals the square root of y plus 2. Solving, let's square root both sides. So x squared equals y plus 2. X squared minus 2 equals y. And then I'm going to write this as y equals x squared minus 2. And kind of keep this off to the side here. So our inverse function, f inverse of x, equals x squared minus 2. Now let's consider the domain and ranges here. So the domain of our original function, f of x, well, we can't have any values in the square root that are less than 0. And so the smallest value that x can be is going to be negative 2. Because negative 2 plus 2 will be 0. So x must be greater than or equal to negative 2. And y, of course, must be greater than or equal to 0. And let's see here. So now let's consider the domain and range of our inverse function. And like the previous example, how I mentioned, typically if we see something like this where we have x squared minus 2, we would say, well, x can be all real values, but we have to take into consideration the original function that we have and look at the range of that original function, because the range of the original function needs to match the domain of the inverse function. So this inverse function is going to have a modification on its domain, and that will be that x must be greater than or equal to 0. And when that is the case, well, when x equals 0, the smallest value that we can have for our range, our y value, will be negative 2. So that means that our range for the inverse function will be that y is greater than or equal to negative 2. And we can see now that the domain and ranges are exactly flipped, and that checks out. That's what we want. And let's see here. And I'll actually graph this one just to kind of show visually what these look like. So the original function, f of x, is going to look something like, well, x plus 2. So it's a square root, and it has a transformation. It's shifted over left 2 units. So it might look something like this. And so this is f of x. And then the inverse function well, it's x squared. It shifted down 2 units. So without the modification on the domain, the inverse would look something like this, right? We would have both of these branches here. But because we restricted the domain here on the inverse function due to the range restriction on the original function, we're going to take that into account here when drawing this out. So the inverse function will actually look something like, our x values are only positive, so it's going to look something like so. And that will be f inverse of x. And like I said, I was going to show the function composition here just to verify that these are actually inverses of each other. So our original function is f of x equals the square root of x plus 2. And the inverse function was f of x equals x squared, f inverse of x equals x squared minus 2. So when we do the composition here, f of f inverse of x equals the square root of x squared minus 2 plus 2, which equals the square root of x squared minus 2 plus 2, which equals, well, the 2's cancel out, and we have the square root of x squared, and those cancel out to just equal x. The other way around, if we have f inverse of f of x, that will be, well, the square root of x plus 2 squared minus 2, which equals the square root and square are going to undo each other. So we're left with x plus 2 minus 2, which equals x plus 2 minus 2. Those 2's cancel, and we're just left with x again. So those are, in fact, the inverses. And that's going to wrap up today's video. I hope you found that helpful. If so, please be sure to like and subscribe. That really helps out. And of course, I'd like to end this video with a little fun fact from philosophy and mathematics. Did you know that Bertrand Russell and Alfred Whitehead, who were both mathematicians and philosophers, they were both they're both they were both proponents of something known as logicism, which is the idea that all of mathematics can be reduced down to pure logic.